In this video, I'm going to show you how to change the user-defined limits for velocity, current, and torque in the CMMT drive. You may need to change these values so that you can limit the amount of torque that can be applied on an object through either the torque or current settings, or you might need to limit the max velocity that the axis can move in case you send the wrong value from your PLC. I'm also going to show you the types of errors that can be caused by having a velocity, torque, or current that is too low. First, let's open up the project. Open up my plugin. I'm already connected to my drive. Under parameterization, I'm going to scroll down to axis 1, axis. And at the very bottom here, I have my user-defined limits. So these limits are not going to cause an error because this is setting the max value. So you will not get a lower limit velocity exceeded because I'm limiting how fast the axis can actually move. If I want to throw off an error, if I did exceed either velocity, torque, or current, I can go under my monitoring functions. You can see here my limit velocity or my I2T monitoring functions. So this is how I throw off an error if I exceeded a value. But under these axis and user-defined limits, I can set what the maximum value is. Now these initial values are going to be dependent on the drive, the motor you're using, and the type of axis being used, whether it's rotary or a linear axis. If I highlight the gray box here, it shows me a recommended, which is the value you can use on the system, a default, and a maximum value. What I can do is I can select this recommended minimum value to change it. Automatically change it there. For now, I'm going to leave this current value. And let's try taking a trace of what this current, or what a move profile could look like. And then we can work backwards to say, what happens if I start changing these parameters? Under my record table, I have two records here, moving between two different positions. I can take my PLC control, enable my motor. And let's bring up the drive here. Now when I press play, we can see the axis move. Under diagnosis and trace configuration, I can set up these values here. I'm going to look at my set point and actual position. I have a set point torque and an actual torque, set point velocity and an actual velocity, and then I have my set point and active current. So now while this is moving, I'm going to record a trace. This one is currently set up for 5 seconds. My trace is done, so let's stop the axis, disable it. Okay, so here's a trace that we'll start off with. You can see here, if I click on my actual position, you can see that we're moving from 20 millimeters up to 180 millimeters. This is going to be my set point torque. So you can see the max torque we're using for this move, the velocity curve, and the amount of current being used here on this axis. So let's assume that initially we accidentally have a torque value that's too low. How would I know that this is my issue? So for this move, I use upwards of 0.3 newton meters of torque. But what happens if I limit this torque? Let's say I put a 0.2 newton meter limit on this torque. I'll go back to my user-defined limits. I'm going to change this to 0.2. Okay, so now I'm going to re-enable the motor. I will start my record table again. Okay, so that just caused an error. But what error is it? I have a position following error. So I told you this wasn't going to cause a torque error, right? Because I'm not exceeding my torque limits, but I have a position following error. So what does that look like? I'm going to reset that error, start the drive again. I'm going to start my trace. Got that same error. Okay. So now let's take a look at this trace. I'm going to hide the velocity values because I'm not looking at that right now. Let's first take a look at the position. Combine the axes. So at some point, this actual position was deviating from my set point position. And once the difference between my actual and set point exceeded my limits, I then got an error. But why did that error occur? Let's show the torque on the same graph. I'm going to do the same thing where I combine these axes so they have the same reference here. So I'll zoom into this graph here. Approximately here is where my set point position deviated from my actual position. And if I look at my torque command here, my torque flatlined, this set point torque, flatlined at my limit of 0.2 newton meters. So this is a perfectly flat portion here where it does not exceed that limit. But you can see the set point position or set point torque has changed throughout the whole move until this point. So that might be an indicator to me that this is my culprit here, that my set point torque is too low. So what I can do is go back, change my upper limit value to, here saying recommended max is 2.2, but I know that I'm only going to use 0.3, so I can set this to 1. Now I can clear my error, enable the motor, go back to my record table, and you'll see the motor move fine now. Okay. So now let's go back to this trace that we had. This shows all of my values. I'm going to hide the torque because I don't want to look at that. Now I want to focus in on my velocity limit. Oh, sorry, wrong graph. Hide the torque, hide the current. Now I'm looking at my velocity. So based on the record table, I told the axis to go to 0.25 meters per second as its max velocity. But what happens if I have an upper limit of this velocity that is lower than my user-defined limit? I'll go back to my parameterization. I'll change this upper limit value from 0.25, and I'm going to change this to 0.2, let's say. Turn the motor on again. Start the record table. And I'm going to trace this. Okay. So I also got an error for this one. Same thing, same error, position following error. But let's take a look at the trace for this. I'm going to hide the torque and the current. And for now, I'll hide the velocity. Okay. Put these on the same axis. And we have basically the same graph, it looks like. You can see that my actual position deviated from my set point position. And once the difference between this actual to the set point exceeded the threshold, it caused an error. So now let's take a look at the velocity that we had at that same time. Combine these on the same graph. Okay. So now there's a deviation here between my set point or actual position and set point position. So let's zoom in. And that's set point value velocity. So I know that we set in the move that I want to be able to reach 0.25 meters per second, but this velocity cut off at 0.2. So the move expected to be able to travel at 0.25 meters per second, but then my user-defined limit limited me to 0.2 meters per second. And therefore, the actual position was not able to keep up with the set point value. And so why would it not scream out to me that's a torque issue? Well, if I hide the velocity and show the torque, combine these axes, you can see that there's no clear, at the point of where the position deviated, there's no clear limit to this torque. You can see that it was using all the torque that I was expecting to use, and there wasn't a peak or a flat line, which would show that over a certain amount of period of time, it throttled the torque down. Okay, so now I'll go back and increase my upper limit velocity. For this one, I could use 3 meters per second, but I'm just going to play it safe and let's do 0.5. I will enable the motor. Oh, acknowledge, enable, start this record table again. And the axis is moving fine again. So now let's manipulate the current. If I go back to that original trace, this is where the system was running as expected. I'm going to hide the velocity, pull up the current again. And now let's look at the max value of the current I'm using. Combine these axes. So my current is about 0.7, let's say, for the max. So what happens if I limit this peak current and say I can't use anything more than 0.5 amps? So I'll go back to my limits here, change this to 0.5, enable the motor. I will start the move. I'll start a trace. And now I get an error. And this is the same exact error. But again, this isn't a current error. It's not saying it's exceeding the current limit. It's bouncing off this current limit and causing a following error. So now I'll go to my trace. I'm going to hide the torque, velocity. I just want to see the position here. So again, same thing that we've seen for the other two limits. There's a point where my actual position is deviating from my set point position. The difference is exceeding the threshold and causing this following error. So now I will show, actually I'll show these positions still, but now I'm going to bring up my current. Put these on the same graph. Okay. So now let's zoom out. Roughly here is where the position is deviating from the set point. And you can see that our set point current is flatlining at 0.5 amps, which is that same number from our user-defined limit. And so at the same point where the position is deviating, we are now flatlining at our peak value. And if I go back to my user-defined limits, I'm going to change the upper limit for my current back to 3 amps. Clear the error, turn the motor on, start my record table. Now the axis is moving fine again. These user-defined limits can be used to intentionally decrease either the velocity, torque, or current to protect the equipment that you're running with, or you may have to increase these values depending on the behavior of the system. And we can typically figure out which parameter needs to be changed based on the type of error, and then using our trace tool to be able to figure out what is the behavior of the system. We can monitor the position if we're getting a position following error. We can monitor our acceleration if we're getting an acceleration following error, and we can compare that to these 3 basic user-defined limits to determine which one is the culprit.